Hello viewers, you are welcome to T-Ben Math class. In today's lesson, we're going to look at vectors. Before we go into it, let us look at the definition of a vector. A vector is any quantity that has both magnitude and direction. Examples are acceleration, force, displacement, weight, momentum, etc. There are other examples, but some of them have been given here. Having gotten the definition of a vector, we are going to look at vector representation. Vector representation is all about how vectors are written. And looking at what we have here, a vector can be represented in any of these forms. So A, we have magnitude bearing form. Example is here. Vector OA is equal to r theta, where r represents the magnitude, length, or distance of the vector, and theta represents the direction. So r is for the magnitude, the length or distance, and then theta is for direction. Now the second form is component form, and we have two of them here, or two ways in which component form vectors can be written. Now the first one is xy. When you see it like this, it means that it has been written in a column form. Then when you see xi plus yj, this one has also been written in Cartesian form. So this one is column form and this one is Cartesian form. Note, a vector can be written as a free vector. Example is here, AB with an arrow on top. The arrow shows that the vector, the direction of the vector is from A to B, or as a position vector. An example is here, we have OA. That is, this one is from the point of origin. So we have OA or small a deepened. So when you see a deepened small a, it means that it is a vector. Now let's look at the first example, talking of how vectors are represented. So the example is, given that Hambo and Ebo move from the same point 0, 0 towards a school, if Hambo walks 12 units to the right and 5 units upward, while Ebo moves 10 units to the left and 6 units upward, express their positions as column vectors. So looking at the question, Ebo and Hambo are all moving from the same point, and there is the point of origin, O. So the coordinates are 0, 0. So for you to be able to represent this one as a column vector, or each of them as a column vector, what you need to do is that you need to make use of your Cartesian plane. So when you draw your Cartesian plane like this, we know that when you draw it like this, this one is for y, and y, we have the positive side and we have the negative side, and then this one is for x, we have the positive side and then we have the negative side. In order for us to know their vectors, we should take into consideration where they are moving to, whether they are moving to the right hand side of x, the left hand side of x, or either they are moving to the upward of y or downward of y. So let's see, with Hambo's movement, Hambo is moving 12 units to the right. So 12 units to the right means that Hambo is moving in this direction. So it is at the positive side of x. It means that for Hambo, her position vector will be OH or simply H. And this will be, we know that when we are writing vectors, column vectors, X comes before Y. So the X part is where Hambo is moving 12 units to the right. So it means that because at the right X is positive, it will be 12. And then let's see the other part or the other component. And 5 units upward. So let's see. If it is upward, what does it mean? It means that Hambo is moving in the direction where Y is positive. So upward is here, positive. It means that Y will be 5. So this will be the position vector for Hambo's movement. Now let's talk about that of Ebo. Now we already know that here is positive Y, positive X, negative Y, negative X. So let's quickly look at it. Ebo moves 10 units to the left. So if Ebo is moving to the left, it means that Ebo is coming to this side. When Ebo is coming to this side, it means that the direction is in the negative part of X. So Ebo's vector will be represented as this, or simply E. And it will be, now for the first part, it is negative and it is 10 units. So you are going to have negative 10, and then he also moves 6 units upward. Upward means that a boy is going to the positive side of Y. So if it is the positive side of Y, then it means that a boy will be moving upward like this. So it will be 6. So these are the answers for Hambo's and Ebo's movements. So Hambo's is this, Ebo's is this. Now let's consider our example 2. Example 2 says that if a motion represented by vector mn, which is equal to 7i minus 4j, is the translation of a particle on the ij plane from m to n, represents vector mn as a component vector. So looking at this, we have been given the vector in the ij form, that is the Cartesian form. So what it means is that in order to write this one as a component form, you should know the one that is represented by, or the one that represents x, and the one that represents y. So let's see. The vector given is this. So we have 7i minus 4j. Always in a Cartesian form, the I represents the x component and the j represents the y component. So in the component form, we are going to have mn as 7 negative 4. So this will be the answer. I for x, j for y. In our third example for today, we have Kezia's shop is 72 meters away from her school and the bearing is 95 degrees. Represent the location of Kezia's shop from the school in the magnitude bearing vector form. So looking at this, we have the magnitude as this. That is the distance between Kezia's shop and her school. And then the bearing, the direction, is 95 degrees. So in order to do this, you write the magnitude bearing form will be, so the magnitude comes before the bearing. So we have 72 meters as the distance, as the magnitude, as the length. So it will be 72 meters. And when it comes to the bearing, always when you want to represent an angle as a bearing, it should always be written as a 3-figure bearing. 3-figure bearing. So when you look at this, we have only 2 figures, 9 and 5. In order to make it 3, we put 0 or we write 0 in front of the 9 so that the digits will be 3. So we will have 095 degrees. So this is the answer. So if you want to leave it as a bearing, make sure it is in 3 digits. 3 digits. So if it is 1, you add 2 zeros to it. If it is 2, you add 1 zero to it. But if it's already in 3 digits, you leave it like that. So this will be the magnitude bearing form of the location of Kezia's shop from the school. Before we bring today's lesson to an end, I would like to give you a prior question. And the question is, a boy moves a particle of force 15 Newton on a bearing of 135 degrees. Represent the force the boy uses in a magnitude bearing form. So this is the question that you have. So do it. Put your solution at the comment section. If you really found this video useful, subscribe to my channel and like the video as well. We will meet another time for another lesson. Until then, goodbye.